Welcome to the video tutorial for day 3 homework. These are pages 9, 10, 11, and 12 in the new homework packets. They're attached, we just printed them a little bit separate. So today what we're doing is predicting products. So we're doing synthesis, decomposition, and combustion. So if we're taking a look, let's look at number 3 down here. It says lithium plus nitrogen. Also, just a fair reminder, in class, if you were absent, we've got these 7 diatomic elements. Okay? Come talk to your teacher if you were absent. But it makes a hockey stick and a puck on the periodic table. Hydrogen, back here, is the puck. Alright? And then you've got your hockey stick, like this. It makes it 7. So I taught my students it's a 7 on the periodic table. 1, 2, 3, 4, 5, 6, 7 of them. Those are elements that never fly solo. They're always twins. They're Siamese twins. They're diatomic, 2 atoms is what di means. Okay. So looking down here at lithium, the word equation, lithium plus nitrogen, is going to make lithium nitride. Lithium is in family 1, so it always makes a +1. It does not need a Roman numeral. But we're naming here, just like we did in Unit 4. Calcium plus sulfur, calcium sulfide, calcium oxide up top. So you're finishing the word equation. You just predicted the product. Now you need to write the skeleton equation. So the symbols, basically, is what we're doing. Lithium is Li. Nitrogen is not N. It's N2, because it is one of the 7 diatomic elements. Again, if you were absent, you might need to talk to your teacher about getting some of those notes. And then we're going to predict the product for lithium nitride. It's not just Lin, okay? That's not how those ones work. So we're writing the formula. Here's the name. You need to write the formula. And formula writing are 4 steps for formula writing. Symbols, Lin, okay? Then you write the charges. Lithium's in family 1, so it makes a +1. Nitrogen's in family 15, so it needs 3 more to be like family 18, -3. Then we crisscross. Then we reduce and erase. So Li, 3, N. Okay. For the rest of the homework packet, we would just have you balance in front of it. But for this one, we were just trying to show you how they're different, like in this example. So I'm going to rewrite it just on this page. Blank Li plus blank N2 yields blank Li, 3, N, like this. And now we're balancing, just like we did on the last homework video. We're going to cut this in half and write down what we have. We have lithium and nitrogen. Lithium and nitrogen. Now we count atoms. I have 1 lithium on my reactant side, 2 nitrogen on the reactant side, 3 lithium on the product side, and 1 nitrogen on the product side. So now that we have this, we can go back and balance. So top down. I need to make this one into a 3. So I'm going to say times 3 equals 3. In order to make that happen, I'll put the 3 up here. Okay, now it's 1 times 3 is 3 lithium. Okay, I need to make this one a 2. So we're going to go times 2. Whoopsie. Look what happened. This 2 distributes to the N. Yep, so now I have 2 nitrogen. But I also have 6 lithium now. So I'm going to come back and scratch out my work. And start over on lithium. Okay. So instead of trying to get it to 3 like I was before, I'm trying to get it to 6 now. So I'm going to then say times 6 will give me 6 lithium on my reactant side. 2 times 3, 6 lithium on my product side. 2 times 1, 2 nitrogen, and 2 nitrogen. So it will be 6 to 1 to 2. Like this. 6 to 1 to 2. That's what my coefficients are. So you just predicted the products, wrote the formula, and balanced the formula. That's really impressive, guys. You need 6 parts of this plus 1 part of that. We're going to give you 2 parts of lithium nitride. Good stuff. Alright. So that was an example of, let me see, like this. This one's down here. Okay, so these are kind of goofy. But it's the same thing. All they're showing you up here is that it's, I think, transitive problem. I don't remember which property of math that is, but A plus B is the same as B plus A. So instead of saying the metal first like we were, the metal plus the nonmetal, we can flip it. It doesn't always work like that, where it's the nonmetal plus the metal. Okay. Oxygen plus aluminum isn't oxygen alumide or something like that. It's still name the nonmetal, cation, name the metal, the cation, name the nonmetal, change it to ide. So this would still be aluminum oxide, and calcium nitride, and sulfur, and then magnesium sulfide. So let's do this last one together. Magnesium sulfide. Okay. You name the metal, name the nonmetal, change it to ide. So, coming down here, writing the balanced equation, I'm going to leave blank Mg plus blank S. Now, sulfur is not one of my diatomics, so it's not S2, it's just S. Yields. And then for magnesium sulfide, to write the formula, I do the 4 steps. Symbols, there's step 1. Charges, there's step 2. Crisscross, there's step 3. Reduce and erase. Now the 2's go away because they're both the same. So my formula is going to be blank Mg S with no subscripts. So when I cut this in half and show my work, I have 1 and 1 over here on my reactant side. On my product side, I have 1 and 1, so I have nothing to balance. It's already balanced. 1 to 1 to 1 to 1. KO. We'll take it. Alright, let's look at decomposition reactions then. Decomposition are the exact opposite. I'm showing you up here in the example, sodium iodide breaks up into sodium and iodine. Okay. So, we did this one in class. Potassium nitride breaks up into potassium and nitrogen. Let's take a look at this one. Let's do number 15, potassium sulfate. Potassium and sulfate will decompose into potassium plus sulfate. Right? Because sulfate on the periodic table stays sulfate, so we don't change the ending. Okay. Lithium sulfide will decompose into lithium plus sulfur. So I'm decomposing from one thing and I'm breaking apart into 2 things. Lithium plus sulfur. So writing the balanced equation, I'm going to say blank lithium sulfide. And I can't just stick letters together, LIS. You have to write formulas, okay, which means you need to do the steps. Lithium, sulfur, plus 1, minus 2. Okay, so sulfur's in family 16, so it needs 2 more electrons to be like family 18. So when we crisscross, Li2S. You have to write the formulas, no guessing, otherwise you're going to balance it totally wrong because it's not the right formula. And that decomposes into blank Li for lithium plus blank S for sulfur. And remember, sulfur is not part of the diatomic 7. Okay, so sulfur is just S, it's not S2. Then when we cut this in half, I've got lithium and sulfur on both sides. Got 2 lithium to start with and 1 sulfur, and then 1 on 1 on this side. Balancing from the top down. To turn this one into a 1, I change the coefficient so I can multiply by 2. 1 times 2 is 2, and putting a 2 there doesn't change anything else. It only changes lithium. And I've got 2 and 2 lithium, 1 and 1 sulfur, so I'm done. 1 to 2 to 1. So you just figured out that lithium sulfide decomposes according to this balanced chemical equation. That's good chemistry, y'all. Real exciting. Okay, combustion reactions are the easiest to predict products because the products of combustion reactions are always carbon dioxide and water. Ta-da! Nice and easy. Always carbon dioxide and water. So, you can come through on all of these and write carbon dioxide plus water. Okay, for all of the word equation products. Let's look at number 4. Carbon dioxide plus water. So on an exam or a quiz, we don't tell you, hey, predict the products of this combustion reaction. You have to figure out that it was combustion. And you do that by noticing that it's CHO reactions. It's a CHO reaction. So for the formula equation, we told you that butane is C4H10. So you're going to leave room to balance blank C4H10 plus blank oxygen. Now, oxygen is one of the diatomic 7 Brinkelhoff. So we're going to put O2 like that for oxygen. Yields blank CO2 for carbon dioxide plus blank H2O for water. Now remember, predicting products for combustion reactions are easy. Writing formulas for combustion reactions, not so much. Balancing, rather. CHO, CHO. So I'm going to write it 4, 10, and 2. Those are my number of those elements on my reactant side. On my product side, I'm going to say 1, 2, and blank. I'm going to completely ignore oxygen when I'm balancing combustion reactions to start with. Okay. So I'm going to go times 4 in order to get my carbon into a 4. Putting a 4 there will change my oxygen, but I'm ignoring that for now. Hydrogen, I'm going to go 2 times 5 in order to get it to be 10. So now I have, ooh, look at that. Look what I just did. I did 10 times 2, 20. Alright, good thing I wrote in pencil this time. I want to go 5 times 2 equals 10. Now my answer matches my work. And now we can go back and consider oxygen. So what I have here is 4 times 2 oxygen. So right here represents 8 oxygen plus 1 oxygen times the coefficient of 5 equals 8 plus 5 is 13 oxygen. So then we say, come back and balance, excuse me, I wrote this wrong, equals 15. Balance oxygen no matter what. So 2 times blank equals 15. Hang on, I'm going to get my white out. Alright, white out it is. Let me try that again. I don't want to lie to you on this video. 2 times blank equals, look at that, right there. Come on home. 13. Alright, so if pizza's $13 and we're going to split it equally, 2 times what number is going to get us 13? That would be $6.50. So 6.5 times 2 equals 13. So I'm going to come back and say 6.5. That gives me 4 and 4 for carbon, 10 and 10 for hydrogen, 13 and 13 for oxygen. So I can put a 1 there. I'm balanced. Hip hip hooray. Except I'm not allowed to really do a 0.5. It's just a placeholder. So to get rid of the half here, I multiply it by 2 so that the half becomes a whole. And I do that to all of my coefficients. So this is going to become 2, 13, 8, and 10. And I'm going to rewrite that here. 2 to 13 to 8 to 10. There are my coefficients. Problems 9, or pages 9 through 12. Alright, good job, y'all.